All right, welcome back. So I'm going to cover the sum and difference formulas today, if my dog will behave, and do a couple problems. So the first thing we probably need to think about is our formulas for the sum and difference. And I'll just write them up top here. So remember, kind of going back a little ways, if we have cosine of A, and I'm going to do this a little bit differently, minus or plus B, that's equal to cosine of A times cosine of B, and then it's plus or minus sine A sine B. And the thing I want you to remember when we're looking at this is that whatever's on top, so we have a negative on top there, and then a positive on top there. So the things that are on top go together, and the signs that are on the bottom go together. Our second formula, and we derived, I think, cosine A plus B in class. And so our second formula is sine of A, right? This one is plus or minus B is equal to sine A cosine B plus or minus cosine A sine B. And so the difference with this formula is that our signs on the top are the same and the signs on bottom are the same. Okay, so you just need to remember those formulas, and you'll have to remember or memorize those formulas. You're not going to be given any formulas on the test. So here we go for the final exam. We'll just do a couple problems here. So sine of 135. And so the deal is I need to turn the sine of 135 into something, and I'm going to turn it into sine of, we're rewriting 135 degrees. I'm going to rewrite it as 45 degrees plus 90 degrees. And so if I add these two things together, I get 135 degrees. And this hasn't changed my function, but now I can use my sum and difference formulas. So now I have sine of A plus B. And so I'm just going to write everything out. It's going to be sine of 45 times cosine of 90 plus cosine of 45 times sine of 90. And now we're just going to go through and kind of figure some stuff out. Use a different colored ink, make it a little nicer. So sine of 45 degrees, we know that's square root of 2 over 2. And cosine of 90 degrees, when we're multiplying, that's 0. Plus cosine of 45 degrees, that's square root of 2 over 2. And sine of 90 degrees is 1. So the square root of 2 over 2 times 0 is 0. That reduces to 0. Or in this case, it really does cancel. It doesn't reduce. And so now we're left with the square root of 2 over 2. And that's our answer. So pretty simple. Hopefully, we take whatever's in our parentheses, our argument, and we're trying to rewrite it so we can use the sum and difference formulas. And these values are all straight off the unit circle. So, because there's no calculator on the test, we're just going to work our way through. Take a look at problem number 6. And so we've got another sine problem. I'm going to move this down just a little bit. And the way that I'm going to rewrite number 6 is, let's write it as, let's go back to black though. We're going to rewrite it as sine of pi over 4 minus pi over 6. And so we can write these out. Now, you guys, there's multiple ways that you could have rewritten these. And there's not one right way to do it. This is just how I did it. You can get different answers. So we end up with sine of pi over 4 times cosine of pi over 6 minus cosine of a, which is pi over 4, times sine of pi over 6. So we'll switch ink colors. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is the square root of 3 over 2. And we're subtracting. Bring our minus sign down. Cosine of pi over 4 is square root of 2 over 2. And sine of pi over 6 is 1/2. So working right here, what we end up with is square root of 2 times the square root of 3. We're multiplying, and we don't need a common denominator. It just worked out that we have one. If we're multiplying square roots together, then they just multiply together. This becomes the square root of 2 times the square root of 3 is the square root of 6 over 4. And bring down our minus sign. Square root of 2 over 2 times 1/2 is the square root of 2 over 4. And we can rewrite that as the square root of 4 minus the square root of 2 over 4. And we're done. So not terrible. And we're just using these identities or the sum and difference formulas to figure these things out. So let's take a look at, let's do number 10 next. And this says rewrite in terms of sine of x and cosine of x. So this looks like a weird problem, right? But it's basically cosine of a minus b, and we can just write it out that way. So here we go. Cosine a minus b would become cosine of x times cosine of b, which is pi over 4. And then remember, for cosine, our signs change, right? So it's a negative. We're going to add. And this would be sine of x times sine of pi over 4. So come down to our next line. We need to simplify this as much as we can. There's no simplifying cosine of x. That's just cosine of x. Put some parentheses. Cosine of pi over 4 is the square root of 2 over 2. And that's going to be plus sine x doesn't simplify. And sine of pi over 4 is the square root of 2 over 2. We might want to take this one step further. I wouldn't worry about it. I will, just to kind of make things neat. Square root of 2 over 2 is common to both of these. So I'm going to factor out a square root of 2 over 2. And that leaves me with cosine of x plus sine x. And we're done. Not horrible. Not too terrible. We're going to take a look at problem number 14 next. Because it's a beast, actually. Let me do it like this. So plenty of room. Okay. So problem number 14. So this is kind of like this problem, if I remember correctly, a lot of people had trouble with this problem or a problem like this, right? So the thing that we need to remember is that this is sine A cosine B minus, I'm going to write it out. This is the same thing on this side as sine A cosine B minus cosine A sine B. And so we need to figure out what formula this is. So you go back to your sum and difference formulas, and it looks like it's sine of A minus B. So this is sine of A minus B. So this whole thing, this is A, this is B, this is A, this is B. This whole thing becomes sine of 11x minus 6x, and that's equal to, let me erase that. So sine of 11x minus 6x, and that's equal to square root of 3 over 2. We can simplify that. And we end up with, I'm going to try and get myself a bunch of room here. We end up with sine of 5x is equal to square root of 3 over 2. So the catch is we could use inverses and do all these things and solve this, but we need to figure out on the unit circle where sine is equal to 3 halves. And so what happens is we end up with 5x is equal to, we go to our unit circle and we're looking for the square root of 3 over 2 for our sine values. And so we end up with pi over 3 and 2 pi over 3. But this 5 essentially means we're going around the unit circle 5 times. And so this would be our first set of solutions. And if you guys are at home watching these notes, when you get done with this video, I encourage you to graph sine of 5x on Desmos, and then change your intervals and take a look at it and play with it. Maybe I'll upload a video talking about that a little bit later as well, because I know it's been a minute. So I need to essentially use this spot right here. So if I'm looking at my unit circle, I know that pi over 3 is about there. And so what's happening is I'm going around the circle essentially 5 times. So I go around once and I get another pi over 3. But it's not really pi over 3. I went around, I had to add 2 pi to pi over 3. So let me erase that. Sorry about that. So this other value was 2 pi over 3. I need to add, so I'm going to take my pi over 3, and I had to go around the circle 1 complete time, so I'm adding 2 pi to it. I need to get a common denominator, and so I'm going to multiply this 2 pi over 3 times 3 over 3, and we're going to end up with pi over 3 plus 2 times 3 is 6 pi over 3, and that's going to be 7 pi over 3. So this 7 pi over 3, that's going to be my next interval. I'm going to do the exact same thing with 2 pi over 3, and I'm going to add 2 pi to 2 pi over 3. So 2 pi over 3 plus 2 pi, I'm not going to write all the math out, that's equal to 8 pi over 3. You'd have to get a common denominator. So that is equal to 8 pi over 3. There's one more time around, so we're at 2 times around. And so here we went around again. We're just going to keep going around, and we're going to have 5 revolutions. So my next intervals would be 13 pi over 3, 14 pi over 3, and then we have 19 pi over 3, 20 pi over 3. So there's 1, 2, 3. We need one more. So I'm adding 2 pi over 3 to 19 pi over 3, and that gives me 25 pi over 3. And I'm adding 2 pi to 20 pi over 3, and that gives me 26 pi over 3. I'm going to erase all of this. So that's what 5x is equal to, but we're not solving for 5x. We're solving for x. So what I need to do is I need to divide this side by 5. And if I divide by 5, that's the same as multiplying this entire side by 1/5. And so what happens is we get x equals pi over 15, 2 pi over 15, right? Because this 1/5 is multiplying term by term. And so all of our denominators are just going to turn into 15. because all of our denominators are the same. And we're just going to write it out. 7 pi over 15, and then 8 pi over 15, 13 pi over 15, 14 pi over 15. This is super fun. 19 pi over 15, 20 pi over 15, 25 pi over 15, and finally 26 pi over 15. And that's our answers. And we could, looking at this real quickly, it only looks like these two things reduce. And so we could reduce 15 pi over 15 into 4 pi over 3, and 25 pi over 15 would reduce to 5 pi over 15. And so basically that is your answer. So let's take a look at 15. 15, I think, is kind of nice. It's not terrible. We're back in the same boat as we were looking at things before, right? So this is really cosine of A minus B. So this becomes cosine of 2x minus x is equal to 1. So you start with this part, and you have to figure out, is that sine of A plus B, sine of A minus B, cosine of A minus B, and you're just going to look at your formula that you memorized for the test and figure it out. We can simplify this. We know that cosine, if I've got two x's and I take away one x, that's just x, is equal to 1. And so what value, or where is cosine equal to 1? And x has to be equal to 0, and we're done. So that one's pretty simple, down and dirty, fast. You can do 16 the same way. I'll let you play around with 16 on your own.